Okay, for number 5, find the volume of the solid obtained by rotating the region bounded by all this stuff. You'll notice I don't have the graph paper on here. If you want to draw a nice, pretty graph on your quiz, you're welcome to do so. I'm just going to graph enough to get a basic idea of what's going on here. I do want to start with the x and y axes. It does say about the x-axis, so it's going to be a rotation like this, so I kind of want to leave room up and down. If I just go ahead and just assume everything's going to be in the first and second quadrants. If it moves over a little bit, I can always move it. But it says that we're going from x equals 1 to x equals 2. So 1, 2. So imagine vertical lines here. Y equals 0 is just the x-axis. That would be this horizontal line. So 2 vertical lines, a horizontal line. And then finally we have y equals x squared, which 1 squared is 1. And 2 squared is 4, so it would be kind of like that, for that bit. And then again, if I put the rest of those things in, there's my x equals 1, there's my x equals 2, and y equals 0, creating this nice little region right here. And as I've said many times when I'm doing this, always highlight your region some way, shape, or form so you can really get a basis for where everything's at. Now, we're rotating this about the x-axis, so that means that we're going to get a mirror image going downward. So if I come down 1, come down 4, make this little here like this, that's what our region kind of looks like. Again, the main idea of this is that we want to get a basic idea what the region looks like. And in this case, it looks like the disk method will be the most effective way of doing this. So if I go ahead and assume a disk in here, let's make it black, circular cross section, if I just slice it out of there, my circles are moving left and right, which makes it a dx situation. And once I see that, the thing I'm concerned with is the radius, and the radius goes from the x-axis up to the curve, so that's y, and it specifically goes to this curve, which is y equals x squared. So when I draw my circular cross section here and I draw my radius, I want a dx integral, and my radius is y. I'm going to, instead of write y, I'm going to put x squared in my circle. I find the area of my circle, it's pi times whatever the radius is squared. The radius in this case is x squared. So the area of my cross section is going to be pi x to the 4th. And to find the volume using the disk method, I simply have to integrate my area formula. I like to put the pi constant value outside the integral, x to the 4th inside dx. And I'm simply moving the circle starting at x equals 1 and ending at x equals 2. So from 1 to 2. And there's my volume formula for this specific problem. So then I simply have to integrate to solve. So pi will be x to the 5th over 5 from 1 to 2. If I put 2 in, 2 to the 5th is 32 over 5. If I subtract and put 1 in, I'm going to get 1 to the 5th is 1 over 5. So the volume is simply 31 pi over 5 cubic units. And I find if you just put the number at this point, cubic units is, I mean, it's officially what it's supposed to be, but if you get the numerical value, the other part's not that difficult to deal with.